Hi! In this series, I will try to explain key concepts about data structures and some foundational algorithms with a focus on visualization, because I think it's easier to understand the concept when you have a clear example in mind and can explain it in simple words. All examples will have source code attached and you can try it later. The two main objectives of the series are to learn the organization of data structures and how do they work internally, and to understand how does an algorithm work and how to implement one from scratch. So, what is a data structure, what is an algorithm, and why do we often use these words together? An official definition would say that a data structure is a data organization, management, and storage format that is usually chosen for efficient access to data. Or, in other words, it is a way of organizing data. An algorithm is a finite sequence of rigorous instructions typically used to solve a class of specific problems or to perform a computation. Or, in plain English, it is the way we manipulate our data. One question may appear straight away. Why are there different types of data structures? Well, because data structures have different properties and the problems we are trying to solve have a distinct set of requirements that may suit better one of the data structure types more than another. For example, if you're trying to keep track of a scoreboard in a game you play with your friends, or if you're following an itinerary for your vacation, a simple array list or linked list can satisfy all your needs. Now imagine a group of people waiting at a shop. The lady or mister at the checkout will serve one person at a time, the order of serving being the order that people write at the checkout. This is also known as the first in, first out principle, and the corresponding data structure is known as a queue. Another example of a queue could be a continuous integration pipeline inside the software project you are working on. Think about you hitting the gym and working out. Because you need the most heavy weights, you first need to put the lightest one apart and then take what you need. This principle is known as last in, first out, and is applied in a stacked data structure. The same principle can be described by the Hanoi Tower puzzle. In order to take a larger tile, you first need to take a smaller one and put it apart. A phone book is an obvious example of a map data structure, where you have names as keys and phone numbers as values for the corresponding keys. Another example of maps are config files for different frameworks and applications, where you set certain properties to take specified values. When thinking about the tree data structure, the first example that comes into mind is a family tree, with the oldest people being the root and all their children and grandchildren descending from them. Or you can think about a file system tree, like this example of a Unix hierarchy. One amazingly beautiful example of a graph data structure is created by all the flights between the cities of the world. Or by creating a simple 3D visualization of a social network. Using all these data structures, we can create algorithms that involve recursion, searching, sorting, and many other things in order to solve real-world problems. So, in this series you'll learn about array list, linked list, queue, stack, map, tree, graph, data structure manipulation, recursion, searching, sorting, backtracking, greedy, and more. See you in the next video.